Good morning, good afternoon. It's Miss Salser from Burr Middle School, 7th grade math. Thought I'd let you see my face before we get started on today's lesson video. Wanted to say hi, that I miss you, that I miss being back at school with the regular schedule. I know that Miss Hughes, Miss Munoz, and Miss Sainer all feel the same way, but we're trying our best to provide you lessons to get you ready for 8th grade math still. So last week it was composite figures that Miss Munoz put a video up for that. So this week it's solving equations. So let's go ahead and get started.
Okay, so here we go. Today we are working on solving equations. Some things to refresh our memories on of some vocab that we're going to hear and see are variable, which are those letters that represent an unknown number. We're also going to talk about the inverse operation. This is the operation that undoes an action. The operation used to undo an action. Usually a lot of times we think of it as the opposite. Like the opposite of addition is subtraction. The opposite of multiplication is division. So a lot of times those will undo each other's actions. So a lot of times that's what we think of when we talk about these. There is going to be one example I'll do at the end of the video that has a fraction, and it's going to be different with a fraction. It is still the inverse operation because it's an operation used to undo an action, but it's a little bit harder to explain than just saying the opposite. Luckily, when we're just doing adding and subtracting, multiplying, dividing though, we can use these exact setups here. All right, so let's go ahead and begin with taking notes over this. I'm gonna have my first example here that we're gonna work out together. My example here is 11 equals 4x minus 21. All right, now I'll leave some space over here. I'm gonna write down the steps on this side on what we need to do for this. So step one, if you haven't done so already, if you have some notebook paper, pen, pencils, color markers, highlighters, it'd be good for you to get these out so you can write these things down to help refresh your brain over this concept since it's been a while since we've done it. So we want to write down equation. We want to write down the equation. After we write down the equation, we want to draw a vertical line under the equal sign. Now vertical, just like in basketball, vertical has to do with up and down. So vertical is the line, just like the L in the word vertical at the end. It's the line that has to do with up and down. Basketball players, they ask what's their vertical. They're asking how high they can go up and down and jumping. So that would be a line that's moving up and down. All right, so once I've got this vertical line, I've got my equation written down, we've started our setup. Our third step is working this problem backwards. When you were in 5th and 6th grade, you learned something called PEMDAS, or order of operations. P for parentheses, E for exponents, M and D for multiply and divide, and then A and S for add and subtract. That is the order of how to solve it when you are given all the information. When you're missing information, you have to solve it backwards, or you're using it backwards. Since we're going backwards in solving this equation, we're going to start by undoing any addition or subtraction. So we are going to undo any addition or subtraction. So any addition or subtraction using the inverse operation. So on here, we've got a minus 21. We need to undo the minus 21 by doing the inverse operation, which is adding 21. And the thing that I always like to talk about in class is the golden rule of algebra. The golden rule of algebra is whatever you do to one side, you must do the other. So the golden rule, whatever I do to one side of the equal sign, I must do the other side of the equal sign. So if I'm adding 21 here, gotta add 21 here. Minus 21 plus 21, that zeroes out. So that will like cancel each other out to where all I have left on this equal sign, this side of it, is a 4x. And it's gonna equal whatever the 11 plus 21 was, which that is 32. My next step, since I'm working backwards, is to undo any multiplication or division. So I'm gonna undo any multiplication or division with the inverse operation. And luckily in 7th grade, this is as far as it gets for us. We don't have to worry about the other parts of that yet. When you get to 8th grade, they're gonna add a little bit more to this. All right, so I'm gonna undo any multiplication or division that I have here. Side by side, I have right here, they're multiplying by 4. So I need to undo a multiplication of 4, so I have to do the opposite, which is divide by 4. Whatever I do to one side, I must do to the other. So my x is gonna equal 32 divided by 4. 32 divided by 4 is 8, so x equals 8. If I wanted to check my work, I can plug that in to see if it works. 4 right here would be times 8, so I could say, all right, if I wanted to work that out, I can come down here and see if it really does work. 4 times 8 is 32. 32 minus 21 equals 11, which is the exact number that we had here. So this is kind of the notes to refresh on that. We're gonna do a few example problems as well. So let me go ahead and get another page set up. So if you need to turn your paper over or get another page, now would be a good time to pause the video and get that going. So we're gonna go ahead and turn this over and do some example problems. Do some practice together. All right, I'm gonna do 3 questions with you. First one is 9 equals 3x minus 30. Write the equation down, draw my line under my equal sign. I need to undo any addition or subtraction first, so I need to get rid of this minus 30. So I do the inverse operation, which is adding 30. To get rid of a minus 30, I do the opposite, so add 30. Whatever I do to one side, I'm gonna do to the other, so plus 30. That zeroes out. So then I have 3x on this side, and then I need to put those together, 30 plus 9, 39. So I've undone my addition and subtraction. Now I need to undo my multiplication or division using my inverse operation. They have a 3 with the x, so 3 side by side, that means they're multiplying. So we're gonna do the opposite action, which is divide by 3. And whatever I do to one side of the equal sign, I must do the other side due to the golden rule of algebra. So now I need to do 39 divided by 3 to figure out what's gonna stay here. All I have remaining on this side is an x. So 39 divided by 3 is 13. So x equals 13. All right, let's try another example problem. I'll come over here. This other example problem, I have 10 equals negative 2x minus 8. Now this has negative in it. We are going to need to refresh our memory on our rules when it comes to positive and negative integers. So be good to look back at that on notes or look at this other video that I'm also going to put up over our integer rules, refreshing those. All right, so I wrote down my equation. Draw my line, vertical line under my equal sign. I need to undo any addition or subtraction first. So I gotta get rid of this minus 8 by using its inverse operation or opposite, which would be plus 8. Whatever I do to one side, must do to the other. That zeroes out. I still have a negative 2x on this side. 10 plus 8 is 18. Now I need to undo any multiplication or division. So if they're multiplying by a negative 2, I've got to divide by negative 2 to get rid of that and move that over. This will turn into a 1, which just makes it 1x. So all I have left is 1x there, because those cancel each other out. And then 18 divided by negative 2. When it comes to refreshing over multiplication and division of positive and negative numbers, you're gonna go ahead and multiply and divide like normal. 18 divided by 2 is 9. And then same sign, it's a positive answer. Different signs, it's a negative answer. This was a positive, this is a negative. They're different, so it's a -9. All right. If I want to check my answer, I plug that -9 into the equation and work it out, and I should get the same answer. Okay, I'm going to do one more example and then one with a fraction. This one, I told you I was going to do one with a fraction. I'm going to do one with a fraction also. 17 minus 3x equals -7 is my third practice problem with you here. I've got my equation written down. Second step, draw my vertical line underneath my equal sign. Undo any addition or subtraction first. Here's where things get tricky. This minus sign is not with the 17. This minus sign is actually with the 3. It takes the sign of whatever's in front of it. So this is technically a positive 17. I need to get rid of a positive 17. In order to do that, the opposite is minusing 17. Whatever I do to one side, to get rid of it, I gotta do the other. That will get rid of that 17, and that minus sign technically is with that 3, so it makes it a 3x, a -3x. This is my integer rules again. If you have any way of making a number line somewhere at home to help out, if this part is stressing you out, I would do so. So I'm gonna have -7, and I have 17 hops going in the negative direction, meaning it's getting smaller. So -7, -8, -9, so forth, so on. You could hop all the way, and if you keep hopping, -8, -9, -10, -11, -12, I'm not stopping at -17. I'm actually having to do 17 hops all the way. So that's hop 1, hop 2, hop 3, 4, 5, 6, 7, 8, 9, 10. I need 7 more hops than what I just did there. Or, if you remember, they're the same, they look like the same sign, find their sum. Sum means to add, so I'm gonna put these two together. I'm gonna add 17 plus 7. I get 24. Same sign, find their sum, and they keep the sign. So it's gonna be a -24. All right, so I've undone any addition or subtraction. I still have a -3x remaining here. It equals -24. Now I need to undo any multiplication or division. So I'm gonna divide by -3 because it's multiplying by -3. Whatever I do to one side, I must do to the other. This will cancel each other out and just make it 1x. And then now I have -24 divided by -3. 24 divided by 3 is 8. A negative divided by a negative. Same sign, answers positive, different signs, answers negative when it comes to the multiplication and division rules. Multiplication, division have different rules than addition, subtraction. So if you need to go back and refresh over that video, please do so. Negative and a negative, they're the same sign, so it's going to be positive answer. Answer is a positive 8. Okay, and then I said I would do one with a fraction, just to throw that in the mix to explain a little bit more with the inverse operation being a little different there. So I'm going to have 2 plus 1/3 x equals -4. All right, I've written my equation down and draw my line under my equal sign. I need to undo any addition or subtraction. I have a +2 here that's on its own. I need to get rid of it. So I'm going to -2. Whatever I do to one side, I must do to the other according to the golden rule of algebra. This zeroes out. I still have a 1/3 x over here. And then -4 minus 2. This is where that number line could be helpful if I wasn't quite sure. -4 minus 2 means I'm going 2 hops in the smaller direction. So -5, -6. So 1/3 x equals -6. Now here's where the weird part comes. When it comes to the fraction and you're looking for the inverse operation or the inverse action, what undoes it? To make 1/3 go away, I multiply it by 3/1. This makes it go away because 3 times 1 is 3 and 1 times 3 is 3, which then just simplifies. that just simplifies to 3 over 3, which is the same thing as just 1. So it's really just 1x. When you work it out, it just becomes 1x, which we don't ever put a 1 in front of it, we just say x. So the inverse when it comes to the fractions is you just flip and multiply it by the inverse of the fraction. So whatever I do to one side though, if I do multiply by 3 over 1 to get rid of this, I need to multiply this one by 3 over 1. And so I'm multiplying a whole number, 6. So I'm going to put 6 over 1 times 3 over 1. Negative 6 times 3, that is a negative 18. 1 times 1 is 18. Or is 1. Sorry, 1 times 1 is 1. Oops, I said that wrong. So now I have negative 18 divided by 1, which is the same thing as negative 18. I hope this helped. If you're seeing the integer rules or what's really getting you, I'd go and watch the video that I have available for integer rules, refreshing that. Okay, thank you. Bye.